So welcome you all. Today we will see the CFD analysis of multiple turn pulsating heat pipe. So this is the geometry of a single turn pulsating heat pipe, which has been prepared with the help of design modeler. This is the air section and this is your water section. So this geometry has been prepared and all the zones are been specified as a fluid. So slice operations are being used over here. A number of planes are used to separate out the geometry so that it can be easily defined with the condenser and evaporator section. So this will be your water zone where the fluid will be present. This will be your air zone, which out of which this particular part will be specified as a condenser, whereas this one will be specified as a heater. So the condenser area is kept larger than your heater section so that there will be effective evaporation and condensation process that will take place. So this is how regarding to the geometry which has been prepared. Now the next one, a part which is related to the mesh. So in the mesh is been generated over here. So the heater and condenser sections are been specified separately. So this is a heater and this is your condenser. Uh, the mesh which has been generated with the help of a default option which has been available. With this, if you want, we can change the size of the mesh also. If you want a more accurate result, so the size of the mesh can also be changed. Now the next part which is related to your fluent. So here the material, first one we have multi-phase fluid, multi-phase model has been selected. Then the energy equation has been taken into consideration. It has been made standard K epsilon, enhanced wall treatment, thermal effect, and curvature corrections are been taken into consideration in this case. So K epsilon, enhanced wall treatment, thermal effects, and curvature correction. So this is the thing which has been taken into consideration. Apart from that, we say in models there are two phases. First one steam, uh, water, that is sorry, water vapor and water. The secondary phase, that is water liquid, has been specified. Then at the same time phase interaction has been specified. So water steam, that is evaporation condensation, and the temperature at which the water will start converting into liquid, so that will also has been specified. So these are a few things which are related. Surface tension coefficient is also been specified over here. So this is regarding the model. Then we have applied the operating conditions, that is 4000 pascals, that is the pressure which has been applied. Before that there is a material which has been specified, water liquid, water vapor, and we say the copper is also one material which has been specified over here. Then boundary conditions, where we are applying the boundary conditions. The boundary conditions are applied at heater. Only the temperature is applied at the heater. Then at the walls, we have specified the contact angle. So this is how the boundary conditions are applied. Next thing is initialization is been done. In the initialization, the patching is done with water as a volume fraction 1, and it has been patched with water. The next thing is calculation activities. So here it is autosave option has been used, and at the same time some simulation is also been set. The simulation which is set over here is the water liquid volume fraction, and this is which we are able to see over here. Now next thing is which is regarding to the type of we can say time step we have taken is adaptive time step. The number of time step which was taken earlier was 500, and accordingly the calculation has been performed. Actually this is already performed calculations up to 500, and we can say for this the things are been observed. So one more time we'll start the calculation. So here, so you can see the alternate liquid vapor slug formation has started. So again it takes some time because if you want to visualize the complete evaporation and condensation process, we have to wait for longer time step. So longer time step will show us the process of evaporation and condensation, the liquid vapor slug which are been formed, and they are traveling towards the condenser section, and at the same time whatever the vapor was present, it will transform into a liquid. So all such process will be visualized when we are performing this we can say simulation for longer number of time step. This is very important because we are uh, predicting the flow of fluid. Like if before experimentation, we must predict based upon the boundary conditions which we are having. So based upon that, whether the fluid any dry out has been taking place or not. So such things can be easily predicted before the actual experimentation has been done. So this CFD simulation is very helpful in order to understand the behavior of the fluid which will take place inside the closed capillary tube, or more specifically we can say as a pulsating heat pipe. So this is very helpful, and it is we say the cost of experimentation can be considerably reduced if we can say that such simulation results are being visualized, and then we can definitely go for this best working fluid which will perform better in the given operating condition. If in such cases if you observed the dry out has been taking place, then in such case a different working fluid has to be selected which will be basically which will be suitable for higher operating temperature ranges. So that can also be one of the option that can be predicted based upon what simulation results you are getting, or what the visualization you are getting with the help of the fluid flow which is taking place. So we'll wait for some time, and then we'll check out how whether we are getting the alternate liquid vapor slug. We'll try to do this with a maximum number of time step, and then we'll predict the flow visualization. So as the iteration process is running on, we are around 7 to 8,000 6,897 time step. You can see in the animation that we have some alternate liquid and vapor slugs are there. So the flow development is in right direction. So we might need to wait for some more time. We might need to we say run it for more number of time steps. As of now, total around 7,600, 6,892 has been there. So in order to best visualize this, to have the whole process of evaporation and condensation, we might need to run it for longer number of time steps. So sometimes the error can also occur, like floating point exception error, or the current number greater than 250. So such kind of errors can occur in the so if such occurs, there is no such actually solution as of now, um, because we cannot resume the iteration process in that case. Might need to go back to the mesh and change the size of the mesh. That is one of the option has been available, and start the whole process from the we can say initial. So this is one thing which can be done. Again, not ensure that whether the same problem will come or not, but this is the thing which can be tried. So we are up to 50,000, 11,046 time steps. We'll just try to see how the visualization will be there. You can see the fluid has been flowing. You may take it to 50 also to visualize in better way how the fluid is flowing, whether it is flowing from right to left or left to right, or whether the process of evaporation condensation is taking place. So this can be visualized with the help of the animation option available. Still, it will not be sufficient to we can say conclude out of it. So we might need to run this for maybe 50,000 time step, so as to visualize the things in better way. So we are up to 17,000 time steps. I'll just check it out how the fluid flow simulation has been there with the help of the playback option available here. So as of now, with 17,000 time step, it shows there is a liquid and vapor slug which is moving. But still, it may not be sufficient to comment on this, because we need to identify whether it is following a pattern of alternate liquid vapor slug which is moving towards evaporator and condensation section. So few more time steps will be required to proceed with the any kind of conclusion whether this will be suitable or not. So as of now it is 17,000 time steps. I will go on with more number of time steps from there. So welcome you all. This is 16th of October. Still we are running the simulation. It is somewhere around 7 lakh iterations has been performed. We'll just check how many time steps has been completed. It is somewhere around, okay, it goes too fast. So it is, I think we are around 35,000 time steps. Okay, this goes very fast because of it is not visualized. Still we are observing the liquid and vapor slug which have been flowing inside the tube, so that indicates that still the we can say dry out condition has not reached, and this working fluid which we have selected as water is suitable for this particular operating temperature range. We'll just go on to continue this iterations for longer duration of time. Okay, 35,300. So this is up to 35,300 iterations we have performed. So till this time, no, we can say the tryout has been takes place. So this will be the best fluid when we are using this for this operating temperature range. So that's it about this simulation. We will run it for around 10 lakh iteration. Still, I think 15,000 time steps are been remaining. So we'll continue that, and after that we'll go on to check out how the simulation has been there. Okay. So let's check with the simulation. Okay. So I'll just run it for say 5 iterations and just check it out how many iterations has been performed till date. It is 18th of October. We are almost 10 lakh of iterations which has been performed. Okay, so just see here. So 50,000 time step we already completed, and it is uh, almost 10 lakh of iterations. And just check it out, this one. This is how the flow pattern is been available. We cannot visualize this here because of we can say the system was closed in between. So that's why we need to go to the post processor, and so we want to see the result. So as of now, first of all, I will save this work. Once it has been saved, I can close the Fluent window. We'll close this file, and then definitely we can go to the post processor and just check out what has been happening. So first of all, click on edit. It may not be directly available at the instance, so you can, okay, so it may not be directly available at the instance, so you might be observing some circles over here, so you might not relate this. So click on this here, so you can see the part which has been coming, then this one and this one. So one by one the whole parts will come out for your object. It depends on how you want to keep it, like you can make it slightly aligned so that we can say all the things, all the details can be there. So as of now it is uh, I need to set transparency over here. Say for example 0.9, you might observe it becomes transparent. Same thing, I had to go for this also. You can take 0.9 and make it apply. Remaining this two also has to be do the same. This one it is 0.9. I kept this. Now you can see just changes in what has been happening. This is 0.9. Make it apply. So likewise the things are being done. Now it's time to uh, have the fluid zone which is present. So I'm just considering the volume rendering. Then in that case, what we want to visualize, that is the water volume fraction that has to be included, and make it apply. At the same time, you will be observing some legend on the left hand side over here. You can change the resolution also, maybe 200, or you can take it 100 also, but it takes a long time to complete that simulation. So it depends on the individual choice what you want to do. Then on this left hand side you can see a legend. Where you want this legend, if I want to at the center, you can take it to the center also. Then you may take it fixed. So just check what is happening. So this scale has been changed. The number of values which you want, you can take it, say 11. Why it is 11? Like it will show 1.1, 0.2, 0.3 kind of thing. Precision, if you want less, you can make it less also. It depends as an individual choice. Yeah, this is all things are there. You may change the aspect ratio, and you may change this particular limit also. Just check it out. Okay, like this it's happening. uh, if I take this somewhere, uh, and let's take it this one. So likewise things can happen. You may make it slightly better as per your choice. So likewise this has been done. So make it apply. So in this way the things are being done to make it better visualization. Then in addition to that, we need to add a few things. So click on text and go to the like say this is time step. So I will just keep it the time step near to the center. You may take it first as file date, which will be select the location left, that's top, and make it apply. So the file date has come here. Then you may enter one more text. So this one here, and let's take it say whichever you want. So let's say time value. Then where you want, say I left and this is bottom. So you can see here time value. So likewise the things can be added. The right hand side will add one more text, say here. Then again it can be just a name, I will say, file name. Say for example I have single. Now which working fluid is been used. Say water working fluid is used. You may specify the location also. Say for example right, and we are saying bottom, so it will come on the right bottom. So likewise things can be added. Yeah, file name I will specify, say here. Okay, so where you want again center. So I will say right, and then I will say cylinder. So you may see it is on the other side. So likewise the things can be added. One more time, one thing important is a time step that I'm going to add uh, over here. So where you want, take it to the center. You may take this center also, so it will come somewhere here. If you don't want at this location, you may slightly change the location. Say for example here I may this take this to center and this will take top. So likewise you can adjust your uh, image and put the time step over there. So this is how the things can be done. Now the next time is to use this save these files which can be done. First of all you click on save movie. First of all select the folder which uh, you want to save. uh, First of all I will create a new folder so that the things will be easy. Singleton. Okay, so I'm saving it to the file was prepared from 11th October. So I will see accordingly little bit 11th October, and here you can specify the, say for example, first of all what you are saying, water volume fraction. This was done till the 50,000 time steps, so I will say 50,000 over here, so that will be easy for us to rectify. Now next thing is to check it out, how we want to save it. Say I want to save it to HD file, so it has been specified there. Then you can click on the advanced button, then save as image file also. Means I need to save the file as image also and video also, so in that case I can go with. So this is singleton pulsating heat pipe which was been specified. So the frame rate you can specify. I will keep it to the maximum value, that is a 60, and keep it highest over here. So this will give you better quality of the image. In addition to that you can make we say some customized also between keeping over here this is 60 and the highest. So make it check out where you are saved the work and make it okay. Now one more additional thing which you can have is uh, you may save these things, uh, you may save these things with the help of better resolution also. Like I had taken 20, I will just show you how it is there when it is taken 100. So you might observe something different. Say for example if you are going with the resolution, you might see some different visualization and better the resolutions can be a different one. So this can be observed, but again the thing is the time required will be a different one when you are going for this. So I'm going back to 20 again and just check it out whether there are any variations. Earlier it was quite blue, now it is somewhere we say light blue. Now if I go 200, it will be again too much of blue color which will be available inside. So these things can be adjusted, but again if you are taking it to 100 as a resolution, definitely the time required will be quite higher than we can say what we are expecting. So if you are comfortable with, accordingly I'm just keeping as 20 because that is visualized over here. So make it apply, and the last time which you can do is you can save the work so that whatever the progress you are done, it will be saved within that file. And just one more time save the project so as to confirm what we had done. Okay, and this one, the last thing which here is you can see in front of them all are right click, so that will definitely want to help us when you are opening this file next time. And once that has been done, you just click on this save button and the files will be saved in that particular you can say range. So it can take some time, maybe it can take some uh, 5 to 6 hours. It depends as a how much big your file size is, so accordingly things can be done. So I'm not doing this as of now because it will uh, last for maybe some around 7 to 8 hours. So I will try to prepare it to do it maybe in the evening so that I can monitor this throughout till the morning. So this you can click on play button and the video files and other things will be getting saved. So just I will not save here as of now. I will close this window and close the post processor window also. So just check it, close. Yes, in front of all of them should be right click so as to we can say visualize these things later on. So this is all about how settings can be done in post processor.